Okay, Cass, I'm about to do another little mini lecture to address a point that I keep getting for a lot of the homeworks. Question number 4 on homework 2.4 is asking for something that might be very unfamiliar to a lot of you guys. Here's the issue. In a nutshell, it's asking you for your opinion, right? Read what number 4 says. Number 4 says, estimating R. So essentially, we want you to estimate R, right? Now, that estimate could be accurate, could be wrong, but we just want you to apply a little bit of critical thinking towards it. For each of the following problems, estimate the value of the linear correlation coefficient R, right? Now, in order to answer this question, you must know how R operates, right? Now, if you remember from what we talked about before, from looking at some of these activities, we should know that R ranges from -1 to +1. We're never going to get an R value that's greater than either one of those extremes, right? We also know that in the middle is 0, is where you pretty much have no relationship that exists. So that's what we know about R thus far. It ranges from -1 to +1. So I'm asking for an estimate, but the estimate that you give me must be between those two values. And we know also that 0 is right there in the middle, which is saying that we don't necessarily think there's a relationship between these two variables. Okay, so let's go back and look at what we're asking. For each of the following, we're going to estimate the value of the linear correlation coefficient R for the given paired data obtained for 50 randomly selected adults. So our N, if you pay attention to that right there, is our sample size. Our N equals 50. Right? That's the information that we gain from that. And we are estimating our value of R, which we know ranges from, let's put it right here, R must be less than +1, but greater than I think that's right. Right? Now, an example, I'm not going to do the one that's in the textbook to give you the answer, but the same aspect can allow you to sit back and think about this critically. Finger length is measured in inches, and those same fingers are recorded in centimeters. I just sent the text out to my family members, and I got first five people that sat back there and let me know their finger length, right? 7-inch finger, 6.5-inch finger, 8.25, 8.5, and 7.5. Now, I say finger length. I'm not really talking about finger length. They actually measured from, you can see this right here, this point right here, all the way up to the tip of this long finger right there. So not really finger length, but all the way down to about right there, right? Is measure that length, right? Now, just like this example, we measured them again and had them send it to us in centimeters. Real talk, I ain't gonna lie to you. I didn't make them measure it twice. I just went to an inches to centimeters conversion, and I put these graph on here. Now, I want to show you something that the textbook, in my mind, does not do a good job of going into. So we're going to sit back there and we're going to draw a scatter plot, right? Now, the first variable, 2, we're going to do 4, we're going to do 6, then we're going to do 8, we're going to make that 10. We move this around. So we got 4 here, 8 right there. And this right here is inches. Right? Then we're going to do centimeters right here. Right? Now over here, we're going to start off at 5, 10, 15, and then we'll do 20 right here. we're going to estimate the value of this. Now, we might need a piece of paper, or we might just sit back and do it in our heads. I would ask you to sit back and think a little bit about it. I'm going above and beyond because I want to show you a larger issue about this aspect, right? So let's look at the first one, 7 inches. 6, 7 would be right there in the middle. And then that would translate to 17.78 centimeters. So that's 15, 17 is right there in the middle. That's our first baby. 6.5, 4, 6, 7 is there, 6.5 is right here. We're gonna go up to 15, right? But then 16.5 would probably be right about there. Then let's do 8.25. 8, that would be 9. 8.25 would be right here. And we're gonna go up here to 20. So we'll go past that line and just a little bit more, so about 21. 8.5, 8.5 will be right there. We're going to go all the way up to 20. 21 is there, so we're close to like 21.5 right there. Then the last person who gave me a response was 7.25. So that's 6, 7, 7.5, 7.5, not 7.25. I'm sorry. 7.5 is right here. So that would be here. We're going to go up to 19. 19 is right by the 20, but just a little bit less than. All right. Now, let's sit back and estimate with this. So this is what it would look like, right? This right here, wait a minute. If I'm not mistaken, this is damn near a straight line. Now, I'm not using graph paper, right? But that is a straight line. One of the things that this textbook does not go into great detail for, and I was looking over, we're talking with some of you guys a couple of seconds ago, is letting you guys know if you have a data value and then you multiply it by some constant. That's like, say you have 1, 2, 3, 4, 5, and you multiply it by all those values by 5. So you won't have 1, 2, 3, 4, 5. The next value will be 5, 10, 15, 20. If you plot those variables against each other, and the only way that they are different is because they're multiplied by a constant or some type of conversion, they will always be a positive 1. So when you look at this data, this is those rare instances, which I talked about in class, in which our data value is actually 1.0. Why? Because for every movement this way, there is an equal amount of change that occurred on the other axis. The same thing can be said this, for every equal movement this way, there's an equal change. Remember I said before, if Jasmine moves one step and the other person moves another step, this is right here showing you how this movement is depicted. For every step up, we have the same amount of change going the other direction. Let's do one more different color so it can pop out differently. Same thing here. For every measure over, you have that same exact matched length upward. This is the unique and only case in which you would sit back and have R value of equal to 1. Now, that's just something that you kind of have to sit back and know. These other variables, what you really need to do is just sit back and give me an estimate. Remember, the key word that I think we're losing and forgetting here is we want you to estimate R. So in your mind, you want to sit back and think, all right, if we're talking about finger length and then finger length measured in inches and centimeters, that's going to be damn near the same. If we're sitting back there thinking about a person's IQ score and how many hours of sleep they had last night, I can't imagine any meaningful relationship that would exist between those two things. So I think that might be around a weak value of 0.12, close to 0. Or I might think it might be slightly negative. So it might be a negative 0.12, close to 0. I'm looking for your opinion. And like I said before, this is unique because I think many of us in psychology, we are so used to finding the correct answer. Please realize and relax that what we're doing right here is asking you for your opinion. And what you want to do, it needs to be an informed opinion. You want to think critically about these variables and if anything might exist. And then even more important than that, we want you to think critically about what R value you think would represent this relationship. I'm going to stop there just so that we don't extend this conversation too long and it's not useful for all of you.